Then I hope everyone doing well. Today let's discuss important topic, dipole moments. What is a dipole? When two equal and opposite charges are separated by certain distance is called a dipole. That is, this is positive charge and this is negative charge. This is Q plus, this is Q minus. Two equal and opposite charges, and this is their distance D, and that is called a dipole. So what is a bond dipole? Because we apply these two molecules, what is a bond dipole? There is a bond dipole when the dipole is associated to a polar covalent bond, then it is called a bond dipole. When the dipole is associated to polar covalent bond, then it is called a bond dipole. So let us a polar covalent bond HA. Let H more negative, that is delta minus, and S is less electron, that is it carries delta plus. So that is a polar bond, right? And that is the Q plus charge, and this is Q minus charge, and that is called a bond dipole. So this is called a bond dipole because now here the positive negative is separated by a covalent bond, that is called bond dipole. That means when a dipole is associated with a polar covalent bond, that is called a bond dipole. Okay. Now let's discuss what is dipole moment. So dipole moment predict the extent of polarity present in a covalent molecules. So dipole moment predict the extent of polarity present in a covalent molecules. Extent of polarity present in a covalent molecule is called dipole moments, and this dipole moment is indicated by mu, and that is as a vector quantity. This is a vector quantity. Dipole moment is a vector quantity. That means it have both magnitude as well as direction. Like we study in physics, vector quantity, magnitude as well as directions. Magnitude as well as directions. So let this is a polar bond, this is delta plus, and this is delta minus. So this direction is from plus towards minus. This is the arrowhead from plus towards minus, that is the directions, and its magnitude is, let is the distance d. This is the distance d between A and B. So its magnitude of dipole is Q into d, where Q charge at any pole and d distance between the dipole. Distance between dipole. So that is its dipole moment. This is the magnitude Q into d, and the direction from plus towards minus. Okay. And the unit of dipole moment is mu is dy. 1 dy is equal to 10 to the power minus 18 electrostatic unit into centimeter. That is the unit of dipole moment. 1 dy is 10 to the minus 18 electrostatic unit into centimeter. Now, calculation of dipole moment. How to calculate dipole moment? To calculate dipole moment, you have to know the shape and the bond angle of the molecules. Let us, this is a molecule, polyatomic molecules, let A and this is B. Let this is delta plus and this is delta minus. A and B is more electronegative, hence B carry delta minus and A carry delta plus. These are two polar bond, AB and this AB. Let's is dipole mu1, this is also mu1. Let this is mu2. Now it is the angle theta. Theta is the angle between these two bond dipoles. This is a bond dipole, this is a bond dipole, this is the angle theta. So according to, since the magnitude of dipole moment like vector additions, so you do determine the mu is, the magnitude is magnitude of dipole moment is obtained by vector addition. That is studied in physics, vector additions. So if the angle theta, so its magnitude is mu1 square plus mu2 square to mu1 mu2 cos theta. So that is its magnitudes. So its direction will become from this to this. This is the direction and this is magnitude mu1 square mu2 square to mu1 mu2 cos theta angle between these two bond dipoles. Application dipole moment. Application of dipole moment. First application, to know whether a molecule is polar or non-polar. Polar or non-polar. So you know, if the net dipole moment of a polyatomic molecule is 0, that molecule is a non-polar molecules. It's a non-polar molecules. If mu, that is dipole not equal to 0, net dipole moment of the molecule is not 0, then that is a polar molecules. That is a polar molecules. That is the one application. So let us we apply this how a molecule is polar and non-polar. Example. Let us use CCl4, BF3, water, ammonia. Now predict which is polar, which is non-polar molecules. Now you have to determine the dipole moment. So if you write the shape of CCl4, this is tetrahedral. So by applying VSP theory, you can write the shape of molecule. This is carbon tetrachlorides. So these are polar bonds. This is a polar bond. Delta minus, delta plus, delta minus, delta minus, delta minus. So you have four bond dipoles are there. This is the directions. And this molecule is a regular molecules according to VSPR theory. So the vector total net vector addition will be 0. Net vector addition will be 0. With all these 4 bond dipoles will cancel, the net dipole 0. Hence this molecule is what? Non-polar. So CCl4, the non-polar molecule, it have polar bonds. It have 4 polar bonds. Still the molecule is non-polar because the net dipole moment is 0. And let us take BF3. If we write the shape of BF3 according to VSPR theory, this is trigonal planar. Now all angles are 120 degree. That is also regular molecules according to VSPR theory. The regular molecules. So here 3 bond dipoles there. This is a BA bond. This is a BA bond. 3 bond dipoles then. So according to vector additions. So according to vector addition, the net dipole moment will be 0. So net dipole moment will be 0 because they are regular molecules. Hence this molecule is non-polar. If net dipole moment is 0, then it is non-polar. And next, water. What is polar non-polar? We write the shape of molecule according to VSPR theory. So this is 2 lone pair. The shape is V shape. Now this is a bond dipole and this is a bond dipoles. Now here the net vector additions will never be 0. Hence, since net dipole not 0 according to vector addition, so water is a which molecules? Polar molecules. The polar molecules. Similarly, ammonia. Ammonia, NH3, if we write its shape according to VSPR theory, that is a lone pair and 3 NH bonds are there, and that shape is pyramidal shape. Pyramidal shape. That is the irregular molecule according to VSPR theory. Irregular molecules. So this is 3 bond dipoles. Now the net dipole cannot be 0 according to vector addition. So mu not equal 0. Hence this is a polar molecule. So ammonia is a polar molecule. So by applying dipole moment, we can predict whether a molecule is polar and non-polar. That is one of the application. And the second application is to determine the percentage of ionic character in a covalent bond. Second application, to predict percentage of ionic characters in a polar covalent bond. Percentage of ionic character in a polar covalent bond. So percentage of ionic character is the actual dipole moment, that is observed dipole moment, actual dipole moment by upon the theoretical dipole moment into 100. The ratio will determine the percentage of ionic character present in a polar covalent bond. Actual amount, that is explain determine, theoretical dipole moment determine. Theoretical dipole moment is calculated by considering bond is ionic. So you determine theoretical dipole, you have to consider the bond is ionic, then we can calculate its theoretical dipole. So actual dipole upon theoretical dipole into 100 will give percentage ionic character of the covalent bonds. So these are applications. Thank you.